Okay, so now we're talking about 6.3, gears and gearboxes in the bottom of page 144. Gears are also an area that it's probably less common for you to have to replace gears, but gears need to get replaced on many gearboxes. Many gearboxes now are sealed. They're relatively inexpensive. If they fail, you just replace the entire gearbox. In some cases, you replace the entire combination gear and motor. So they're called gear motors. But in many cases out in the real world, you will need to be able to assess gears and potentially replace them. So a gear is simply a pulley with teeth cut into it. And this is very old school technology. All of these are very old school. Gears were used as far back as ancient Greeks, and they were used all through the Middle Ages, and clocks and gears were synonymous. They worked together, and that's sort of the beginning of science and technology. So there's a lot out there about the gears. So you're going to learn about the pitch. You're going to learn about the diameter, how you measure the diameter of a gear. Okay, you're going to learn about that sort of thing. It's important to understand how to calculate gear ratios, and you always calculate the larger diameter gear over the smaller diameter. And that ratio determines, number one, how I change the speed of rotation from one gear to the next, and determines how I can increase or decrease the amount of torque that I can apply, or the power that can be applied through a gear ratio. The common rule of thumb is, for everything, if I increase the speed and make something spin up faster, then I'm decreasing the amount of power. If I decrease the speed, then I increase the amount of power. That's why I use a lower gear ratio to get myself more torque, and a higher gear ratio to get myself more speed. And if anybody who's driven any kind of standard vehicle, you recognize that as a way of driving your car. If you use your, if anybody here uses a stick shift. All right, so your most common gear is called the spur gear. That's typically the gear that everyone thinks about. That's what these guys are. That's what this one is. We've got a bunch of other gears out there, and they've got pictures of them: bevel, miter, helical, herringbone. These become less common in the real world, though you will see them in gearboxes, and obviously the bevel gear you're going to see in your vehicle for your rack and pinion steering. So read about them. The herringbone gears are especially interesting, and they kind of create a self-alignment. We've got worm gears and so forth. Section 6-4, speed calculation. I'm not going to heavily emphasize that, but these are where you find your pulleys, your formulas for doing your speed calculation for two different size pulleys. Or you can use the same approach for gears as well. And the book takes you through how you calculate your different speeds depending on two different sizes, and it takes you through clockwise versus counterclockwise, because a clockwise gear is going to spin the one next to it counterclockwise, and vice versa. So when you get a whole bunch of gears lined up against each other, one spins one direction and it pushes the other one the other direction, and so on and so forth. So it's all sort of pretty obvious once you think about it. But the book takes you through some lovely drawings and describes how that works. That's pretty much it, all I want to talk about in the book.